Welcome back. Day 2 of the 65-day O-level IGCSE Maths Challenge. If you made it through day 1 and showed up again today, give yourself credit because you have already done what most people don't. You started and you followed up. Today's topic is decimals and fractions. It sounds pretty basic, right? But operations, conversion, simplification, recurring decimals, conversion from decimals to fractions, fractions to decimals, all of these small little things go into more advanced topics. For example, algebra, percentages, and so on. So we're not rushing. We're mastering the basics. We're trying to make sure that our foundations are right, so that when we deal with difficult topics, more advanced topics, we deal with them with razor sharp precision. I hope you know the drill by now. Stay active, take notes, pause, and try yourself before I solve, and download today's worksheet by the end of the class and solve it. And once you're done, comment below. Day 2 is done. Let's master the maths that everybody thinks they already know. Let's get into decimals and fractions. Day 2 starts right now. Okay, so 4 operations. By 4 operations, we mean these are the key fundamental operations in mathematics. The division, we know that. I think you can tell from the signs as well. This is the division, multiplication, addition, and subtraction. I'm sure you've done BODMAS rule or BODMAS rule in grade 7, 6 or 7, I'm sure. Okay, but this is kind of sort of a revision with some updates as well. And the updates is the first thing you have to take care of is this is in the order of priority. This is the order of priority, which means you prioritize whatever is in the bracket first. Okay. Then you prioritize the order. We will talk about that. And then you prioritize the division and then the multiplication and then the addition and subtraction, the poor subtraction by the very, very end. Okay, so the first thing you prioritize is whatever is in the brackets. Okay, and then order. Now, what do we mean by order? Order means the powers, the exponents. Normally, it's also called, some people also call it operators. Okay, which is also fine. Sometimes it applies to operators as well. Operators such as sine theta, and for example, I mean, in higher grades, you will understand, you will learn the d over dx as well. I think sine is the operator, right? Over here, d over dx is the operator, and whatever is the operator is being applied on, that number, I'm writing that thing in the box. Okay, you don't have to understand this. Even if you don't, that's fine. Okay? But normally the order is important. I hope you understand the squares and the cubes, right? I think this is what we will use over here. Okay, so let's take a question. Let's take an exam question. So I'll write BODMAS here. BODMAS. BODMAS. Right. So the first thing I need to take care of is the fraction, is the bracket. So that's the first thing I will do. Right, in the bracket. So whatever is the bracket, I think it's 4 minus 5. So 4 minus 5 is, I think, -1, right? And 2 plus 3. Okay, so we took care of the bracket first. I don't see any order, so I'm not going to, I'll just move on from here because I don't see any exponent or any operator. So I'll just move on from here. And then division, I don't see any division either. And then multiplication. So I see that the 2, I'll actually highlight what I did first. I did this first, and I'm going to do this. Right, so 2 times -1, that would be -2. Then 3 comes along. 3 minus 2 is just 1, so 1 is my answer. Okay, I hope it's not so bad. Evaluate 12 plus 6 divided by 2 minus 8. Okay, so one very important thing, that is any integer has its own sign. Every integer that you see, I mean, in fact, every number that you see, not necessarily an integer, has its own sign, and that is written to the left. Okay, so for example, it's written 4 minus 2. If you were to think about it in terms of the signs, then this 4 has a positive and this negative, and this 2 has a negative sign. Okay, so every number has its own sign, which is written before it. Okay, now I am, if I write BODMAS, if I apply the same BODMAS on this question, let's see how let's see how it goes. Bracket, I don't see any bracket, so I'll put a cross on top of it. I don't see any order either. I see a division, yes. Division between 6 and 2. Actually, positive 6 divided by 2. Okay, so if you do 6 divided by 2, that is, we know that it's 3. 12 plus 3, positive 3 actually, minus 8. So we did division. I don't see any multiplication, so I'll put a cross on it. Then there is addition. I hope you can see addition. 12 plus 3. 12 plus 3, I think, is 15 minus 8. That will be 7. So 7 is my answer for this question. Okay, I hope not so bad. Like this is a revision of grade 8 stuff. Okay. All right. I'll let you do this one. Okay, take a moment. Again, that's the whole point of this video. That you take breaks and you do stuff. Okay, so take a break and solve this, which is your turn, and then we'll move forward. Okay, fractions. This is going to be long. Fractions involves a lot of things, actually. We'll talk about the operations of fractions. We're going to talk about the simplification of fractions. We're going to talk about addition, subtraction, multiplication, addition, proper fractions, improper fractions, a lot of it. Okay? So, and if you've got your fractions right, a lot of the maths is going to be easy for you. Okay, so this is one of the key sections of mathematics, O-level mathematics, and it's going to help you a lot in the further mathematics as well. Right. Addition and subtraction. How do we add and subtract fractions? Well, the rule is same bottom, no problem. If 2 or more fractions have to be added, if you want to add or subtract the fractions, they must have actually the same denominator. In other words, the same bottom. So the bottom bit has to be the same. For example, a divided by c plus b divided by c. So the bottom is the same. Same bottom, no problem. So I could just add the ones on top and I'll write the bottom ones. But that will be my answer. Okay, this is a general rule. To go for addition as well as for subtraction works both ways. Okay, I'm sure you know about this before as well. I don't think it's something very surprising. Okay, so let's take an example. For example, 4 divided by 3 plus 2 divided by 3. The bottom, or in other words, the denominator is the same. I could just write it as 3, and then 4 plus 2, which is 6 divided by 3. Over here, now, I cannot solve this directly, okay, because the denominators are different. You see, we have one of the denominator is 5, the other denominator is 7, which are quite different from each other, right? So I cannot solve it directly. Okay, how can we solve it? We'll talk about it. But for now, I cannot solve it directly. Okay, because why? Because the denominators are not the same. Different denominators. These denominators are different. Next, now we want the same bottom, always, right? So how can we make denominators the same? What do you think? We have a bunch of methods for this one, okay? Everybody has their own preference. This is why I normally try to list down all the methods that are available out there so that you can pick. Sometimes you have no choice but to learn if there is more than one method, but normally you do get a choice to pick between the methods. The first method is called the butterfly method. In other words, the cross multiply method. For example, if you get two fractions, a over b divided by c over d, what you could do is cross multiply this with this guy, multiply with this guy, and then multiply the bottom. So this is what the structure looks like. Okay. This is what it looks like. So you, for example, let's apply on this one. So A times D would be A times D, and actually write it just as AD minus B times C would be C divided by B multiplied by D, because the bottoms are multiplied. Okay, let's apply the same thing on this one. So if I were to multiply 4 with 2, I'll actually write that first. 4 times 2 plus. We did this. Now we'll do the other one. And that is 3 times 1. So 4 times 2 times 3 times 1 divided by, I'll multiply the bottoms, which is 3 times 4. I'm going to get 4 2s are 8 plus 3 divided by 12, 11 over 12. Okay, we can do the same for this one as well. Do the cross multiplication and then multiply the bottom. So 2 times 2 would be 4 plus 7 times 3 divided by 7 times 2. Okay, so 2 times 2 is 4 plus 7 times 3 is 21. 7 times 2 is 14. This would be 25 divided by 14. Okay, I hope it's simple. The butterfly method, also called the cross multiply method. Okay, next is called the LCM method. LCM method means that you multiply the numerator and the denominator. I'll actually put that over here. Multiply the numerator and actually write top and bottom. It's top and bottom of each fraction. This is important. We do it for each fraction. So you multiply the top and bottom of each fraction to make denominators the same. What do we even mean by that? For example, let's take an example. So take a look at this. 2 times 3. I want same denominators. That's my requirement for addition. Okay, so what would I do? If you notice, if I play clever, what I could do is, what is the smallest number that I can make in the denominator? Think about this for a while. That I can easily achieve out of 5 and 3 as well. So what I'm actually trying to look for is, what is the smallest number that 3 and 5 can give me together? Okay? So I think what I'm looking for is actually I'm looking for an LCM indirectly. You can take the LCM, but I wouldn't recommend taking LCM. You could just do this. This is 5 times 3, 3 times 5. Yeah, this is sort of a version of a cross multiplication, but kind of you're thinking about it in terms of the LCM. So you whatever. Now over here, we might have to multiply the top and the bottom of each fraction with the same number. Okay, so whatever number you are multiplying the denominator by, you will also multiply the numerator by the same number. Okay. You multiply the denominator by 5. Now you are obliged to multiply, you are supposed to now multiply the top with the same number as well. Okay. Right, I think it's simple now. So 3 times 3 would be 9 by 15 plus 2 times this would be 10 over 15. So I think that well, I've got what I wanted. I now have the same denominators, right? So I could 15 and 15, right? So I could just write it as a single denominator 15, 9 plus 10, and I'll be left with 19 over 15. Okay. I hope it makes sense. Let's crack some fractions. Let's apply the same methodology and solve some fractions. So this one is pretty simple because the denominator is already the same. So I don't think I need to do anything else on this. I could just write 8 and do 5 plus 1, which is 6 divided by 8. Easy peasy, simple. Next I have is 7 over 9 minus 2 over 3. So if you notice, 7 over 9 minus 2 over 3. What I could do over here, this is 9, right? I can, if I were to multiply 3 by another 3, I can make the denominator 9. The other one is already 9. I don't need to do anything on this. So my problem solved. So if I need to multiply the denominator by 3, I will have to automatically multiply its numerator by 3 as well. Okay, do not go on to multiply the other fraction with it, because we're only operating in a second fraction while we're doing this. Okay, so 7 divided by 9 minus 6 divided by 9, which is, you write it as a single denominator, which is 9. 7 minus 6 is 1 divided by 9. That is your answer, ladies and gentlemen. Right, I think you'll do something like this over here as well. So 4x divided by 15 plus 2x divided by 5. I think what you could do is, so this is already 15. Okay. One is a factor, the other one is a multiple. That's the way to remember it. If one is a factor, the other one the multiple, the other one is the multiple, make both the same by making both the multiples. If it doesn't make sense, that's fine. This is the multiple and this is a factor. Because 5, 10, and 15, you can make it. The list goes on and on. So 15 is a multiple of 5. So what I can do is I can multiply this by 3 and multiply the top by 3 as well. So this will take me 4x divided by 15, nothing changed here. And plus this will be 6x divided by 15. And I think my problem solved. The denominators are the same. I could just write them as a single denominator, and the top will be 4x plus 6x, which is 10x divided by 15, and that is my answer. Okay. This one is also pretty simple. 6 divided by x minus 1 over 2x, right? What I can do is this is 2x, right? Can I make this 2x? Very conveniently, I could just, multiply this by 2 and multiply this by 2 as well. All right, so this will be 12 divided by 2x minus 1 divided by 2x. And this will be, 2x would be at the bottom, and 12 minus 1, which is 11 by 2x, and I am done here. Okay. Now over here, suddenly now we have 3 fractions, but worry not, everything is the same. Now this is 10. I think I should keep it as 10, because I can make 5 a 10, and I can make 4 a 10 as well. Okay. How? Let's see. 3 divided by 5 plus 1 divided by 4 minus 2 divided by 10. So my goal is, if I keep this as 10, my goal is to make the rest of them a 10. So 5 times 4 is 10. So if I'm multiplying the denominator by a number, of course, I'll multiply the numerator by the same number, and by 5 by 5, and I will get 12 divided by 20 from the first fraction. From the second fraction, I'm going to get plus 5 divided by 20 minus, I think I did not change anything in this one. So this, wait a sec. I think if this is 20, if this is 20, I need to make this 20 as well. Yeah. Sorry. Sorry, guys, my bad. If I were to make this 20, I think I'll just multiply by 2, the top and the bottom. So if you notice, every fraction is multiplied by a different number at the top and bottom. It doesn't matter. You can do that, as long as you're getting the same thing in the denominator as a result. Okay, so I think at the top will be 4 divided by 10 times 2 is 20. The denominator is the same, which is 20. I could just write all of it as 12 plus 5 minus 4. I think it will be, so if you remember BODMAS, right, there's no bracket, there's no order, there's no division, there's no multiplication, there is a combination between addition and subtraction. What should I do first? I should do addition first. Okay, so I'll do the addition. 12 plus 5, which is 17. Oopsie daisy. 17 minus 4 divided by 20, which is 13 divided by 20, and that is my answer. So I hope after doing all of these questions, it kind of makes a lot more sense now. But So far, you've watched me doing this. Now, I would encourage you to do this by yourself. Okay? Take a moment and give it a shot by yourself. Again, this is very, very crucial. Okay? The reason that we are doing this challenge is because I want you to do stuff while we are in the class. Okay, that's the key. That's the deal that we've made. That's the deal we've made when we started the challenge. Okay, right. I hope you're done doing this. Let's try something different. How would you add this? Take a moment and try to think about this. How would you add this? The denominators are definitely different. X plus 3x minus 1. What would you do? I think if I were to 5 divided by, we have x plus 1 and plus 2 divided by x minus 3. I think if I could just multiply this by x minus 3 and multiply this by x plus 1, I might get the same denominator. And the whole thing looks pretty huge, and that's fine. But the fact is that it's the same. They're both the same. So we made the denominator big, but also we made it the same. Okay. So if I'm doing this, I need to do this on top as well. Okay. So what will I get? I think if you did algebra in grade 7, I'm sure you know how to do this. Okay, so denominator is x plus 1 times x minus 3. Sorry about that. But for the numerator, okay, so 5 times x would be 5x. 5 times 3 would be negative 15. Okay, plus. Sorry, guys, I'm getting hiccups. 2 multiplied by x would be 2x, right? This would be 2x. Plus 2 multiplied by 1 would be 2. Okay, so I think you can further simplify this now. Like terms with like terms. So 5x plus 2x would be 7x. And then constant with constant. So minus 15 plus 2 would be negative 13 divided by x plus 1 and x minus 3. I know, pretty different, and it looks complicated as well, but that's fine. The thing is, the basic rule does not change. The basic rule is, this is a fraction, this is a fraction. I cannot add them unless the denominators are the same. Simple, plain and simple. Okay, so I found a way to make the denominators the same. The way that I did it is kind of clever, yes, but at the end of the day, the job gets done, right? So, yeah, you will encounter something like this in your past paper exams as well. Again, multiplication, actually, multiplication of fractions is what we are talking about. Okay, to be precise. Multiplication is simple. It's really simple. Top times top, bottom times bottom. Like, it's really simple. No common denominators needed. You don't have to make the denominators common. Right? That's not a necessity. It's not a condition. Okay, which makes things a lot easier. This is why whenever students see a plus or minus sign, they get ew and ew. And whenever they see a multiplication sign, they get happy. Like, I could just multiply top with top, bottom with bottom, and I'll be done. Okay, let's do this. I think 3 times 2 would be 6, 4 times 5 would be 20. Done here. Now, if you look at this number 7 over here, 7 multiplied by 5 divided by 6. Looks like there's a very common confusion that goes on. Students think that sometimes, I mean, not all of them, but some students think that I need to multiply 7 with the numerator and the denominator. That is not true. Why? Because any number, I think we talked about this in integers as well, any number, when it's a standalone number, when it's an integer, there is a hidden 1 in the denominator always, any number. Okay, even if it's a pi, there's a hidden 1 in the denominator. Okay. Now, I think it makes sense now what to do. Top times top, bottom times bottom. Okay, so this one is actually, I could just copy this over here. Okay. So 7 times 5 would be 35 divided by 6 times 1 would be 6, and that is your answer. Okay, I hope it's not so bad. Right. Okay. This is the top and this is the top. So I'll take x plus 2 and I'll multiply it by 6. Okay, divided by 5 times 3, we know that it's 15. Okay. Now you can do the maths on top, right? 6 times x would be 6x. And so it'll be 6x plus 6 times 2 would be 12 divided by 15. I don't think it's that bad. The same thing applies over here as well. This question is actually like question number 2. 2 is actually 2 divided by 1. I hope it helps. So 4 divided by x plus 1 multiplied by 2 divided by 1. So I think top times top, bottom times bottom. 2 times 4 is equal to 1 times x plus 1. That will be 8 divided by x plus 1, and that is my answer. Right? Here, again, no matter how complicated it looks, again, top times top, bottom times bottom. Okay, so take 3 times x plus 3, 2 times x plus, actually x plus 3 times 2, but it means the same thing. X plus 3 times 2. So if you do the multiplication on top, 3 times x would be 3x plus 9. You will get 3x plus 9 at top, and at the bottom 2x plus 3. You can also do it this way, x times 2, and I think it's better to do it this way. So x times, so I will get x times 2 would be 2x plus 6. Okay. Now, do not make a mistake of adding the two numbers, because 3x plus 9, do not make a mistake of adding them because they are not like terms. So I'll just leave it there. Okay. All right. Next, exam prep time 02. This is a past paper question, by the way. Pretty simple, I think. Once we've done this stuff just a while ago, I think this sounds a lot easy now, right? Part A, also part A here. 6 divided by 7 minus 1 divided by 3. What I can do is, I need, this is subtraction, so I want my denominators to be the same. What I could do is multiply this by 3, and the top by 3, and this by 7, and this by 7. What am I going to get? 18 divided by 21 minus 7 divided by 21, which is, the denominator is now the same. So I think I'm all set here. 21. 18 minus 7 would be 11 over 21. And 11 over 21 is your answer. Okay. So I hope it's fine. Part B. Part B is the simplest in the world. 2 divided by 5 times 4 divided by 9. Top times top, bottom times bottom. 2 times 4 would be, so multiply both of them. That would be 8 divided by 9, 5, I think 45. So 8 divided by 45 is my answer. Like, pretty simple, I think. I don't think it's a big deal. It's like, again, it's like revising grade 9, grade 6 or 7, maybe. Okay. I'll let you do this one. Okay. Take a pause and try to do this. Division of fractions, actually. Division of fractions. It's not that bad, it's just a bit different. So fractions don't like to be divided. So what we do is we convert division into multiplication. Yes. So we keep the first fraction the same. The rule is, I call it the KCF rule. Keep, change, flip. What does it even mean? Let's write that down first. So keep first fraction the same. Do not change anything in the first fraction. Change the sign. So I think normally it looks like this. There is a fraction. There's a fraction. There is a division, and there is. I'll give it a name. Let's say A divided by B. And then we have, let's say, c divided by d. So first thing is I do not touch this fraction. The second thing I'll do is change the sign of, actually, change the sign of division to multiplication. Actually, instead of writing the whole thing, I could just write it like this. The division sign, the Ed Sheeran sign, if you remember. I think this is the Ed Sheeran sign, if I'm not wrong. And to multiplication. Okay. And the third thing to do, flip the fraction right after the sign. These are the rules. I'm sure you've done this before. I don't think it's very new. So the first thing I did was I kept the fraction the same. I did not change anything there. So in the next step, I'll write it the same. Now I'll convert this division into multiplication. It'll be multiplication. And I'll flip this guy. So it'll be d divided by c. That's it. That's how we do division. So we're not really doing division here. We're just, avoiding the problem with converting a division problem into a multiplication problem. Okay, just like, people make things other people's problem. Okay. Done. How are you doing it? Right, let's apply a division on this one. So I'm not changing anything in this fraction. I'll write it like this. I'll flip the sign. So flip the sign and change the sign. So this division will now be multiplication, and I'll flip this dude right here. So 2 or 5 will now be 5 divided by 2. And I think multiplication is simple. Top times top, bottom times bottom. So I will get 15 times 15 divided by 8. Okay. The same thing I'll do over here. I will not change anything in the first fraction. So 7 over 9 stays the same. Division turns into multiplication, and this 2 turns into 3 divided by 1. And top times top, so 7 times 3 would be 21, and 9. Okay, again, I'm not changing anything in the first fraction. So the first fraction stays the same, divided by 5, multiplied by, I'm going to flip this fraction, so x plus 2 divided by 3. And we have, if you notice, this is the same thing. I could, instead of writing it twice, I could just put a square on top of it. Divided by 5 times 3 is 15. So we're done taking care of all the operations of fractions, addition, subtraction, division, and multiplication. And I'm also very sure that the reason that I paced through it a bit is because this is grade 6 and 7 stuff. I'm sure you're supposed to know the grade 6 and 7 stuff if you do enter into O levels or IGCSE. Okay. Now it's your turn. Take a moment, give yourself a pause, and try this. Right. Next, very important thing, something muy importante. It's in Spanish, you say, if something is really important, you say muy importante. Okay, fractions. Converting into, this is the reason that I put an important over here is because this is a very commonly seen question in past papers. Okay? You will see a lot of questions saying, well, convert this into the simplest form. What do we mean by that? Let's take a fraction. For example, let's take 1 over 6 as a fraction. If you remember, while we were doing the addition and subtraction, we could multiply the top and the bottom by any number we want. I could multiply it by 7. I could multiply it by 8. I could multiply it by x if I want. I can multiply by anything, right? Let's say multiply it by 2, for example. By 2, I will get 2 divided by 12. Okay? Now, if I can multiply on both sides, can I also not divide on both sides? Kind of makes sense, right? Let's say I have this fraction, for example, 18 divided by 6, let's say. Okay? So it looks like that they're both multiples of 3. So if I can multiply both sides by a number, I can also divide both sides by a number, right? Okay, so 18 divided by 3, what is it? 18, I think it is 6, and 6 divided by 3 is 2. Can I do that again? Yes, I can do it again. 6 divided by 2, 2 divided by 2, and I'm gonna get 6 divided by 2 is 3, 2 is 1, 3 over 1, or just 3. What did I do here? I started with this fraction, 18 over 6, and I ended up with just 3. Okay, so this is where I started, and this is where I ended. Okay, this is where I started, and this is where I ended. So what I'm doing over here is the whole process is called simplifying. Okay, normally we do not bother writing that one number we divided the top and the bottom by. Okay, so normally what it happens is, I'm sure you're also familiar with the word cancellation, right? Everybody loves doing it. So if I have 18 divided by 6, I could just say, well, 6 times 1 is 6, 6 times 3 is 18, and there is 3. You could do it simply. Yes, I know, you can do it simply, right? But what you did over here was, you actually divided both sides by 6, didn't you? This is what you actually did. Okay, and then you realize, okay, 18 divided by 6 is 3, this is 1, so my answer should be 3. Okay, but the point is, we do not normally write these. Okay, what number are we dividing the top and the bottom by? That sometimes it's not important. Okay, so 6 times 1 is 16, 6 times 3 is 18, so 3 divided by 1 or 3. Okay, this is how we will be simplifying fractions further on. Okay, so again, let's fill this, whatever I've written. 1 over 2, if you multiply on top and bottom, you could also divide on top and bottom. Okay, that's the crux of everything that we did over here. Okay, let's simplify a bunch of fractions. Okay, so we have fractions, we have some fractions. Let's simplify them. So take a look at this. What number can I multiply by? I think it looks like that they're both even. So I'll just cancel them out, both of them, by a 2. So 2 6 are 12, 2 8 are 16. If you notice, the fact that I divided both of them by 2, I did not write 2 anywhere. This is the norm that you should get used. I'm dividing both sides by a number, but I'm not writing that number. Okay, so I'll be left with 6 divided by 8. I think I can do this one more time. 2 3s are 6, 2 4s are 8. So I'm left with 3 divided by 4. Can I simplify it any further? Is there a number that divides 3 and 4 both? The answer is no. So apart from 1, of course. So this is the simplest form. We just converted a fraction into the simplest form. Okay. 18 divided by 24. So 18 divided by 24. Normally, I can do this by 6 as well. So I think 6 3s are 18. 6 4s are 24. I got 3 over 4 again. 35 over 49. I think I can divide both sides by 7. So 7 5s are 35, 7 7s are 49. So 5 over 7 is my simplest form. Okay. Simplest form, again, I'm emphasizing on this point. This simplest form is very, very, very important. Muy importante. Okay, now let's talk about the types of fractions. We have 3 types of fractions. We have a proper fraction, we have an improper fraction, and we have something called mixed fraction. Proper fraction, improper fraction, and a mixed fraction. What are they? There's a way of remembering that I remember, and that is proper is bottom heavy. So you have to have the numerator and the denominator should be stronger. It should be heavy from the bottom. Yeah. Bottom heavy. And improper fractions are either top heavy or equally heavy. Which means, let's say if I write 8 divided by 8. Is it a proper fraction or is it an improper fraction? It'll be an improper fraction because the top and the bottom are equally heavy. Okay, they're both same. So I have a bunch of fractions. Real quick, let's classify them into proper and improper fractions. So is this top heavy or bottom heavy? I think this is bottom heavy, so this is proper. This is 7 divided by 4. Top heavy, I think improper. Okay. 9 divided by 10, again bottom heavy, so this guy over here is proper. 12 divided by 12. Now, they're equally heavy. Whatever, if something is equally heavy, what is it? Improper fraction. Okay, so I could just write it as improper fraction. 8 divided by 3, again top heavy, so this is again improper. 5 divided by 9 on the bottom, this is bottom heavy because 9 is bigger than 5. So this is definitely proper. Again, we have equally, what did we say? Yeah, equally heavy. So this is again improper. Okay. Bottom heavy, so this is proper. Top heavy, so this is definitely improper. And this fraction is, I think, equally heavy, so again, improper. Okay, so I hope it gives you a better idea about the proper and the improper fractions. Okay, so now that a fraction is an improper fraction, how would you convert from improper fraction to proper fraction? We can't directly convert proper fraction into improper fraction. We turn it into something called a mixed fraction. So we'll see what a mixed fraction looks like and how does it work. Let's see. So here is what it looks like. Okay. Yeah, mixed form. Call it the mixed form. Okay, so how do we do that? Well, before I introduce you to the mixed form, I'll introduce you to the long division first. Okay, let's go back to grade 7 or maybe grade 5 and understand long division, because in the secret behind converting from improper fraction to mixed form is long division. Okay, so if you think about this, for example, let's take 11 divided by 4. 11 divided by 4 actually means that if I were to write in terms of division, then I would write 4 outside and I would write 11 inside. Okay. Let me do the long division over here. Long division. So I think 4 2s are 8. So that I'm left with 3. So I cannot solve any further. I'll just stop there. Now let's give them names. The thing that's outside, that's commanding everything, this is called the divisor. Okay, we have a name for this guy. We call this a divisor. Okay, this is the divisor. Okay, the one on top is called the quotient. This guy is called the quotient. And the one at the bottom is called, also has a name. It's called the remainder, and this is pretty obvious. The one at the bottom is called the remainder. Okay, so this is the remainder. Okay, so why is this important? Why do we have to know which one is the divisor, quotient, and remainder? Well, so that we can write them in the form of mixed form. What does mixed form look like? In the mixed form, we have a number over here, written rather in a big font, and you have a fraction over here. This is called the mixed form. Now, how would you use long division to convert this into a mixed form? Well, initially I had 11 divided by 4. This is what a mixed form looks like. Q R divided by D. Q R by D, Q R by D, this is what you gotta know. Again, there's no choice for you but to memorize this. Okay, Q R by D. So what's my quotient here? Q means quotient, of course, R is the remainder, and D is the divisor. I think it's pretty obvious. So 11 divided by 4 would be, quotient would be 2, and quotient is 2, remainder is 3, and the divisor is 4. So that's how I would convert this improper fraction into the mixed form by using this format or a pattern called QR by D. Okay, I hope there's no confusion about that. I would really encourage you to stop right here and pause the video and try this. Okay, because I only did one example, I'm going to do more examples from the past paper questions. Okay, so I'll let you do these two questions. Take a moment, give yourself a pause and try this. Okay, I hope you did this already. Now, what if you are, what if you're already given a mixed form? But if you're already given in the mixed form, how would you convert from the mixed form back to the improper fraction? Well, here is a simple trick. You would start from the bottom, okay, and then you would multiply the two numbers. So if the two numbers that is over here, you would multiply the two numbers. These two numbers you would multiply, and after you've done multiplying, whatever the result, add this to your result. Add this to your result. I think I should write it like this. Multiply and add. Well, what do I mean by that? Let's see. Over here, 2 is written as 2 whole 3 by 5. 2 whole 3 by 5. Thus, it is read as 2 whole 3 by 5. Okay, so how would you convert this into improper fraction? Let's say the divisor and the quotient, you multiply them. So 5 2s are 10, and then keep 10 in mind. Keep that in your short-term memory, which is called the RAM, and then add it with 3. So 2 times 5 is 10. 10 plus 3 would be 13. 13 divided by 5 is my improper fraction. Okay, we'll do the same for this one as well. 2 times 4 would be 8. 8 plus 1 is 9. So 9 divided by 2. 8 ones are 8. 8 2 is 16. 8 3 is 24. 24 plus 5 would be 29 divided by 8. Okay. That's how you convert from the mixed form. This is really important because this is used in so many questions. You will be given mixed form of so many questions, and you will be asked to perform operations. You'll be asked to perform multiplication, addition, division, and so on. We'll see in a while the past paper questions. Okay, so it's really important, it's really crucial that you know how to convert from the improper form to the mixed form. Sorry, from the mixed form back to the improper form. Okay, so now we know how to go from improper form to mixed form and how to go from mixed form to improper. To go from improper form is the long division. Okay, and this is I would say this is a trick you follow, and you get back to the improper fraction. Okay, again, I'm emphasizing on this point. This is really crucial because it is going to be seen in a lot of questions coming ahead. All right, let's see. Convert, I will let you do this one. Convert the following into improper fractions. Give it a shot. I would say give this a shot as well. Question 1 and question 2. And also do this. So you have mixed fractions over here. Convert these mixed fractions into improper fractions first and then do the multiplication. So you'll be left with the top and the bottom, multiply by the top and the bottom. Multiply the tops, multiply the bottoms, and you will get your answer. And so we've seen how multiplication works. Okay. Right. I think let's do this one together. This sounds like a different question, I would say. Not necessarily difficult, but different. It is given that 2 divided by 3. Now, previously we talked about this. Let's say you have a fraction 1 divided by 8. Okay. I can multiply both sides by any number, let's say 2, and I'll get another fraction. And the other fraction, let's say, is 2 divided by 16. Now, 1 divided by 8 and 2 divided by 16 are the same fractions. Okay, even though they don't look the same, but not necessarily the same, I would call them equivalent fractions. Equivalent fractions. Okay, you can go back, you can go from here to here, you can go from here to here. You could just do the cancellation, and you would end up where you will end up where you started with, right? So if you divide both sides by 2, 2 divided by 2 is 1, 16 divided by 2 is 8. You'll get back to 1 over 8 where you started with. Okay, you can also keep equivalent. There are unlimited equivalent fractions to a certain fraction. For example, if I divide both sides by 3, 1 divided by 3 would be 3, it will be 24. Okay, I can multiply by 4, for example. 1 4s are 4, 8 4s are 32. I can just keep going on and on. Okay, all of them are equivalent fractions. They're all equivalent to each other. Fraction 1, fraction 2, fraction 3, fraction 4. They're all equivalent to each other. Okay, I'll actually keep it written over here. Right. Now, it is given that 2 divided by 3, 8 divided by d, and n divided by 39 are equivalent fractions. Okay, so let's see. Let me pick up the first pair. So 2 divided by 3 is equal to 8 divided by d. Is that right? So what did you multiply on the top to get 8? I think you multiplied by 4 on top. So you would multiply by the same number at the bottom as well. Okay, so I'll get 2 times 4 is 4, 3 times 4 is 12, is equal to 8 divided by d. So if, sorry, 4 2s are 8. So if this is 8, d should be equal to 12. Okay, so d is equal to 12. Let's do the same for this one as well. 2 over 3 is given. I'll pick up this pair, this and this. Because they're all equivalent to each other, I can put anything against anything. Okay, so now 2 divided by 3 and n divided by 39. Okay, so 3 multiplied by what number is 39? If you do 39 divided by 3, I think you're going to get 13. 3 ones are 3, 3 threes are. Okay, so which means I multiplied 3 with 13 to get 39. Okay, so 2 times 13, I will do the same on the top as well. 2 times 13 would be 26 divided by 39 is equal to n divided by 39. So 39, if 39 is 39, yes, then n is equal to 26. So 26 is my answer. N is equal to 26. Okay, so we kind of cleverly use the idea of equivalent fractions to find the missing parts of its equivalent dudes. Okay, for example, this dude is equivalent to this one, this dude is equivalent to this one. So I would use the complete dude to find out the missing parts of these other friends. Okay, I hope it makes sense. Right. The next section we're going to start is decimals. I think before understanding decimal, let's go back again. Let's go back to grade. I'm sure this is started in grade 4 now. Let's go back to grade 4 and let's understand. These are called place values. I hope you remember place values. So over here, before the decimal, it starts from these are the ones, also called units, tens, hundreds, and thousands. If you go back from over here, this is tenths, hundreds, and thousandth. TH means the 10th part, the 100th part, the 1000th part. I can take up any number. For example, I would say 12.09. Okay, so the place value for 0 would be 10th and place value for 100 would be 9. I can also take up a really big number. For example, I can take a number for an example from here, 800.54. So how would I write this? 008.54. Okay. So make sure that you write numbers. You're able to write numbers beneath their place values. Like if I give you a set of numbers to divide and to add and subtract, then you should be able to first of all place them in the right place values. Okay, so for addition and subtraction, a very simple rule for adding and subtracting decimal is to adjust the numbers according to their place values. That's it. Okay, let's see. Let's take a look at this one. For example, if I have 800.54, right? So I hope you remember this. This is the ones, tens, and hundreds, and this is the 10th, and this is the 100th. Okay. Yes, 10th and 100th. So 90.52, I would write 90.52 accordingly. So 90 is 10th and 5 and 2. Okay. Once you have written on everything on top of each other, it's called stacking. Just like you stack burgers. You put a lower bun first, and then you, for example, for if you like beef burger, you put a beef patty first, right? And then you put in sauces. Maybe you put in some like some sauces, let's say cabbage, iceberg, stuff like that, and you put it in the top bun. Okay. So you do the stacking, right? It's not like you're placing your burger bun is here and your pizza patty is here and your sauce is over there. You don't do it like that. You stack it on top of each other, write one thing on top of each other. Okay. So this is exactly what we do when we are doing the when we're doing the addition or subtraction of decimals. Okay, so I just put that in the trigger your cravings. And yeah. Okay, so if I'm adding, okay, I'm adding, that's how I add. That's how I will add. Okay, so I think adding from this point onwards is simple. It's really great for 5 step. 4 plus 2 is 6, 5 plus 2 is 7. Point 0 is 0, 9 and 8. So 890.76 is as simple as that. Right. 3, 4, 3.4 plus. Okay, so now do it carefully. Okay, so if I have 5 is in the units place or the ones place. So I'll put 5 here. Point 607. This is the 10th place. This is the 100th place. This is the 1000th place. Okay, so I'll put 6 over here. And then 0 and 7. Now the problem is I do not have anything at the 100th and the 1000th place on top. If I don't have anything, I could just put in zeros. Okay, just to make sure that everything is stacking on top of each other just nicely. Okay, so to balance the stacking, I just put in the zeros. I can just add right now. 7 plus 0 is 7, 0, 6 plus 4. Now, 6 plus 4 is 10. Okay. I'll put it 0 here and I'll carry this one on top. I hope you understand the concept of carrying. 5 plus 3 is 8, 8 plus 1 is 9, so there is a 9, and I think the rest just follows. 349.007. Okay, I hope you understand. Again, the reason I'm speeding through this because this is really great for stuff. Okay, I would say I am not really in the mood to do these, so I would let you do this. Okay, give it a shot. I think along with these questions, give these a shot as well. Okay, do this as well. Really simple, not a big deal at all. So give yourself a pause and A, B, C, D, E, and F. Okay, do at least 4. Pick any 4 and do that. Okay, don't do all of it. Don't have to do all of it. It's really simple. Pick any 4 and try it. Okay, give a pause, pick any 4 and give it a shot. All right, I think it's time to move on. Multiplication of decimals. How do we multiply decimals? Okay, so in addition, we stack them on top of each other. When doing multiplication, we pretend that the decimals don't even exist. The decimal points don't even exist. It's funny, right? We pretend that the scary decimal points don't even exist. Right? So for example, if you have, let's say over here, if you have 2.4 times 3.1, first of all, you pretend that these decimal points don't even exist. So you just multiply 24 and 31. That's it. Right? Add the decimal places of the multiplying numbers and put it back in. Okay, so for example, I multiplied the numbers exist, and I would say do the multiplication. Do the multiplication without decimal points. Put that over here. Without decimal points. Okay. All right. So once I do the multiplication without the decimal points, I will add the decimal places of the multiplying number, and I'll put back the decimal places to the resulting number. Okay. So for example, this is one decimal place. This is one decimal place. This is also one decimal place. So one decimal place plus one decimal places would be two decimal places. So at the answer, I would put my decimal at two decimal places. For example, 1 and 2, I'll put my decimal over here. My answer would be 7.44. Okay, so forget about decimals for a while. Just count the number of decimal places, multiply the numbers, and the result, put the added multiplications, added the decimal points in the answer. That's it. That's really it. Okay, let's do this. For example, so I'll forget about the decimal places. This is one decimal place again, and this is again one decimal place. If I were to add them, I'm going to get two decimal places for the answer. Okay, so 5 multiplied by 6 would be 30. Two decimal places. For two decimal places, do not write it as equal to. For two decimal places, it will be 0.30. Okay. Never ever write it like this, like that, because 30 is not equal to 0.30. So it follows from here is my answer. It follows from here that you can also repeat the question. We don't have to use 0.6 multiplied by 0.5 is equal to 0.30. Okay, because we took 30 and we put the decimal places over here. So yeah, right. Okay, I think this is also really simple. So this is one decimal place. This is one decimal place. The answer is two decimal places. 32 multiplied by 14. You're allowed to use calculator for this because I will do that too. 32, I think we don't have to. Let's, I think, do it this way. 32 multiplied by 14. 4 2s are 8. 4 3s are 12. And 32, 8, 4, and 5. So 548 is my answer. If I were to bring this into two decimal places, my answer would be 3.2 multiplied by 1.4 is equal to 5.48 because this is where I'll put my decimal point. Okay. All right. Okay. If you look at this, this is two decimal places because one decimal place and two decimal place. And this is one decimal place. So my answer should be three decimal places, right? And now, if I were to do 8 multiplied by 3, 8 3s are 24. Three decimal places, if you want to. Okay, so this is tricky. I write 24. Three decimal places would be one decimal place, two decimal place, three decimal places. I'll put my decimal over here. What would I put in this pouch, this empty pouch? I'll put a 0. I'll put a 0 outside as well. So my answer is 0.024. So 0.08 times 0.3 is equal to 0.024. Okay, I hope it makes sense. Next one, decimals. How do we divide the decimals? So a way to divide the decimals would be first find a way to get rid of the decimal points. Okay, so we remove them from the status of being decimals. Okay? We get rid of the decimal points first. How do we get rid of the decimal points? Well, first, what happens when you multiply a decimal by a multiple of 10? If you multiply by a decimal, any decimal by a multiple of 10, multiple of 10 means, well, it could be a 10, it could be 100, it could be 1,000, and so on. If you multiply, they're all multiples of 10. Hope you understand the concept from the multiples and factors, right? So if you multiply any decimal by a factor of 10, what happens is, I think it's really simple. What happens is the decimal points move to the right by, decimal points move to the right by the number of zeros. Well, what do we mean by that? For example, how many number of zeros are there in the first one? There is 1 0. So you would just take the decimal point and move it one decimal place forward. Previously, it was 44.7. Now it will be, from 4%, it's going to become 47.0 or just 47. Okay. Now over here, if you notice, there are two decimal places, right? This multiple of 10 has two zeros. two zeros, which means I'm going to move it by 2 decimal. Over here, I removed it by 1 decimal place. I will move it forward by 2 decimal places. Okay, so it's going to become 36.0 or just 36. Okay. Over here, now this is 5.81. I want to move my decimal by three decimal points because you have 3 zeros here. When you have 3 zeros, you just move forward by 3 decimal points. So let's do that. 1, 2, 3. I'll place my decimal point over here. Now, what do I do with this? What do I do with the space? Well, put a 0 in this pouch and put a 0 after that. So in simple words, it is just 5180.0, or even if you write it as 5180, this is also fine. Okay. Now, since we're doing division and not multiplication, this is really important. This whole thing, actually, it's very, very useful in a lot of ways. This is a very, very useful thing. It's going to help you a lot, not just in decimals, but in complex questions as well. Okay, so this is muy importante. Okay, so how does it apply to division? Let's say, for example, I have 4.8 divided by 0.6, so I'll write 4.8. I can also write it as 0.6, right? What I'll do is I'll find a way to get rid of the decimals. So I'll multiply the top. How can I get rid of the decimal? Think about it. I can multiply the top by 10 and the bottom by, make sure, I think we discussed this before as well, make sure the number you're dividing, the numerator or the make sure you divide the top and the bottom by the same number. So move decimal points 1 point forward. This will be 48, and this will just be 6. If you can further simplify it, for example, if you divide both sides by, or cancellation, if you divide both sides by, I think a reasonable thing to do is divide both sides by 3. I'll divide both sides by 3. We normally don't write it. So 48 divided by 3 would be 3 ones are 3, 3, 16. So my answer is 16. Okay, right. 0.72 divided by 0.09. How do we deal with this? Well, first of all, I'll write in the division form, 0.72 divided by 0.09. Now, if you notice, I have 2 decimal places. I have numbers in 2 decimal places after the decimal. So I'll multiply the top and the bottom by 100. A multiple of 10 that has 2 zeros. Okay. So it will, I'll move the decimal 2 points forward on both sides. So this will give me 72 divided by 9. I think 72 divided by 9 is just 9 eighths are 72. So 8 divided by 1, or you can write just 8 is the answer. Over here, also write it 16 divided by 1 or just 16. Okay. Again, it's the same thing over here as well. That 5.25 divided by 0.015. It's going to look like, well, 5.25 divided by 0.015. Now, here's the problem. The problem is if I divide the top by 100, I will get rid of the decimal point because there are 2 decimal points after that. But if I divide the same number by bottom, I will not, my decimal point would land itself over here. I do not want that. So I'll multiply, I need to multiply, to get rid of the decimal, I need to multiply the bottom by 1,000. So I'll multiply the top by the same number as well. This is really important, okay? You cannot divide top and bottom by different numbers. Make sure that you're using the same number to divide the top and the bottom. We've discussed this before. So move the decimal point 3 decimal places, 1, 2, 3. Over here, 1, 2, actually 1, 2, 3. So this will be 5, 2, 5. And there is a pouch, if you notice. I'll put a 0 over here, and this will just be 15. You can further simplify it if you want. I think you could multiply both sides by 5, I think. So you'll be left with the denominator will be 3. The top will be 1, I think, yeah, 1, 0, 5, 0. Yeah. Okay. You can double check on the calculator as well. Okay, so that's how I simplified. That's how I divided. That's how I did the division of the decimals. Okay, 1050 divided by 3, you can perform a long division. And I think you can further divide it by 3. So if you divide it by 3 on both sides, 3 ones are 3, 3 ones are 3, 3 threes are 9, 3, yeah. The answer will be 350 divided by 1 or 3. Okay. Now, how did I know that this number is divisible by 3 or not? Here's a really important tip of, actually put it in the box. How to check if a number is divisible by 3 or not. How to check divisibility by 3. How to check. Add the numbers. Okay. If the sum is divisible by 3, then the number is also divisible by 3. 3. The number is also divisible by 3. Okay. So how did I know right away that 1050 is divisible by 3? Well, take a look. 1050. I want to know if it's divisible by 3 or not. So 1050. I'll take 1 plus 0 plus 5 plus 0. That gives me 6. 6 is divisible by 3. So yes, 1050 is divisible by 3. I've written it way too small, but I hope you get it. Okay, so this is one of the useful tip that is going to help you. Okay, I'll let you try this. Give it a shot. Take a moment. Stop for a while and give it a shot. Try this, and then we'll move forward. Okay, next. Let's do this. These are exam questions. So yeah, let's give it a shot. Part A, I'll do part A here. 1, 2 divided by 3. 1 whole 2 divided by 3 divided by 5. So let's see what I get. 1 whole divided by, if I were to convert it into a fraction, I will get 3 ones are 3 plus 3 ones are 3. 3 plus 2 would be 5. So 5 divided by 3 divided by 5. So I'll 5 by 3. Remember the keep and change and flip rule. So I'll keep the 5 divided by 3. I'll change the sign and I'll flip 1 over 5. Okay, so I think I can cancel out 5 on both sides. 5 ones are 5, so I'll be just left with 1 divided by 3 is my answer for the first bit. Second, 4 1 by 4 minus 1.43. Let's see. So 4 1 by 4, if I were to convert it into improper fraction, that would be 4 times 4 would be 16. 16 plus 1. 4 1 by 4 minus 1.43. 4 4 is a 16 plus 117 divided by 4 minus 1.43. We'll learn this, I think, in a while, that how to convert decimal into fraction. I'll convert this into fraction right away, but we'll learn this in a while. How to convert decimal into fraction, I think it's going to come. Yeah, decimal into fraction. Okay, well, just do this over here. Follow along, and you will learn in a while how to do this. So I'll convert this into a fraction. 17 divided by 4 minus. I want my answer in decimal. Why not convert 17 divided by 4 into a decimal? So 4 and 17. So 4, I think 4 4s are 16, and there is 1 over here. And I put a point, I'll put a 0 here. For 2s are 8. Remainder will be 2. I'll put another 0 here. For 5s are 20. I'm assuming you know the 8 fourth grade division. 4.25. So I got 4.25 minus 1.43. You know how to subtract the decimals. 4.25, 1 minus 4.3, 5 minus 3 is 2, and I'll take borrow from here. This will be 3, 12. I think this will be 8.3 minus 1 is 2. 2.82 is my answer. Okay. Look for the errors. I'm not done this before. Look for the errors. If I've written the answer wrong, you can correct it by yourself, but make sure you do it by yourself. Okay, here, part A. If I were to convert this into improper fraction, that would be 3 2s are 6, 6 plus 4 is 10, 10 divided by 3 multiplied by 1 over 7. So multiply the top and bottom, 10 divided by 7 3s are 21 is my answer. I think we did this before. 2 over 5 multiply by 12 over 7. Can I do any cancellations? No. So 12 times 2 is 24 by 35. Okay, is my answer 10 divided by 21 and 24 by 35. Okay. 0.2 multiplied by 0.06. How do we do this? If you remember, we just did this a while ago, that you forget that the decimal point even existed, right? And then just do 6 multiplied by 2 is equal to 12. Now this is 1 decimal place and this is 2 decimal places. We add them, 3 decimal places. So take the decimal point and move it 3 decimal places backward. So 12, let's say my decimal point is here, 1, 2, 3 decimal points. My decimal point would be here. 0.12 is my answer. Okay, so 0.012 is my answer. Okay, 3 divided by 0.01, we just did this a while ago. 3 divided by 0.01. I want to get rid of the fractions. I want to get rid of the decimal, so I'll multiply this by 100 because there's 2 decimal places. And 3 divided by 100 would be 300 divided by 0.01 multiplied by 100 would be decimal point moving 2 points forward. So if I move it 2 decimal places ahead, I'm going to get 300 divided by 1 or just 300, which is my answer. Okay, I hope it makes sense. Now pause and give it a shot. I'll let you do this by yourself. This is very, very simple. I'll really encourage and I'll really recommend to pause and do it. Right, next, converting decimal into fraction. Well, we have 2 cases for converting fraction into decimal. The first thing we're doing is fraction into decimal, and the second we'll go back from the decimal to the fraction. Like, so how do we go from fraction to decimal? Let's say you have something in a fraction and you want to convert this, write this into something with a decimal point, something like this. How would you do this? Let's say we have a bunch of cases here. Okay, 4 very important cases. I think after that we'll. Okay, so we have 4 really important cases. The first case is when the denominator, in other words, when the bottom is a multiple of 10. This is the simplest case. The bottom is the multiple of 10. Move the decimal point by the number of zeros. I'll move the decimal points to the left by the number of zeros. Okay, so I think this is simple. Take 4 if I'm dividing, move the decimal point. So over here, right now the decimal point is over here. I'm moving decimal points to the left, so it'll be 0.4, 0.4. Okay. Over here it's 100, so I'll move I moved 1 decimal place left. Okay, I'll just write 1 decimal place. Over here, I'll move it 2 decimal places to the left. Okay. So if I were to move it 2 decimal places to the left, this will be 0.37. Right? 506 divided by 1,000, 3 decimal places to the left. Right now my decimal is over here. 1, 2, 3. 3 decimal places to the left. So 0.506 is how I converted the fraction into a decimal when the bottom is the multiple of 10. I think we just talked about this. The multiple of 10 would be like 10, anything that is a 10 or 100 or 1,000, etc. Okay. Next, case number 2. When the bottom is not as clean as simple as a multiple of 10, but it's something that you can be made a multiple of 10. So when the denominator can be made or can be made multiple of 10. Okay, so look out for these numbers. 2 can be converted into 10, we convert it to 100 or 1,000, 4, 5, 20, 25, and 50. Okay, these are the what we call the, I'm not sure you've seen the movie, Usual Suspects. It's a really good movie. So usual suspect, these are the usual suspects. If you find these numbers in the denominator, which means you can somehow convert this into a multiple of 10 and then use the case 1 technique to convert the fractions into decimals. How? Let's find out. These are the normal, for example, if you have 2, just multiply it by 5 on top and bottom to get a 10. If you have 4, multiply the top and bottom by 25 to get 100. If you have a 20, multiply the top and bottom by 5. If you have 50, multiply the top and bottom by 2, and you'll get the multiples of 10. Let's see. So I have 3 divided by 5. I think if I look my table, I can just multiply both sides by 2. Okay, so I'm gonna get 3 2s are 6, 5 2s are 10. I think it will apply. So we have a 10 on top, which means I'll move my decimal points to 1 decimal place to the left. So decimal point right now is over here. It'll be 0.6. Okay. 7 divided by 25. So if you look in the table, 25, if you have 25, you get 25 multiplied by 4 on both sides. 4 on top, multiplying by 4 on top and bottom. So 4 multiplied by 4, and I'm gonna get 7 4. I think 7 4 is at 28, and 25 4s are 100. Now this tells me that I can move my 2 decimal places because the denominator is 100. It has 2 zeros. I'll move my decimal points to the left by 2 decimal points, and this will be 0.28. Okay. 9 divided by 20. What will I multiply both sides by? I'll multiply the top and the bottom. In other words, the numerator and the denominator by 5. So what am I going to get? I think I'm going to get 9 5s of 45 divided by 45 divided by 100. So I'm going to move my move my 2 decimal points to the left. So here, 0.45 is my answer. So I hope you understood case 1 and case 2. When the bottom is a multiple of 10, that's when you could do it right away. And when the bottom is not a multiple of 10, but can be made into a multiple of 10, and over here you have to look out for the usual suspects in the denominator. I'm missing this part. In the denominator. So when you have 2, 4, 5, 20, 25, 20, 25, and 50 in the denominator, you can convert this into a multiple of 10 easily and then turn it into a decimal using the case 1 trick. I believe there's no confusion about that. Third is a pretty hopeless case. You cannot, when the denominator cannot be converted into a multiple of 10, this is when you have a hopeless case. Okay, when the denominator cannot be turned into multiple of 10. Okay, then you would multiply the, you did follow the long division simple. I think long division should be simple. I'm assuming you've done this in grade 4 or 5 or 6. So you'll put 3 outside, you'll put the numerator inside. 3 2s are 6, you're left with 1. Put a point, then you'll get a 0 here. 3 3s are 9, you will get a 1. Put again 0, 3, 9. I think this is going to keep on going on and on. So this is a recurring decimal, 2.33. I'm going to keep getting a 1 here at the bottom. I'm going to keep putting a 0, and I'm going to keep getting a 333 on and on. So I might as well write it as 2.333, or I can also write it as 2.3 with some people put a dot on top, some people put a circle on top. It really means the same thing. It just tells that it just tells me that 3 is a repeating. So this is a recurring decimal. We call it a recurring decimal. 2.3 and 3. You can write it as like this, or you can also write it as 2.3 with a dash on top. Okay, so I hope it makes sense. Okay, let's try another. Right, 5 divided by 8. How would you do this? Again, the same reply. I cannot make the denominator to be, any multiple of 10. So I'll just put 8 outside, 5 inside, the numerator inside, the denominator outside. And I cannot divide right away 5 by 8. So I'll put a 0. I'll put a point here. I'll get a 0 here. 8, 6 or 48, I think. I'll be left with 2. I'll put a 0, 8. No, it was 16, 3 is 24. 8 1 0, 2 0, 16. I know my maths is bad, kind of. Right, so 16, I will be left with a, oh my God, what am I doing? I'll be left with a 4, I'll put a 0, but 8 5s are 40, so we'll cancel out. I'll get nothing at the bottom. So as I performed long division on it, I'll just make it smaller. Okay, so I got 0.625, simple. And this is a terminating decimal. It ends here. Okay. So I hope the 3 cases make sense. When you can do nothing, this is a hopeless case. This always works. Hopeless case always works because it's pretty hopeless. Next, case 4. In case 4, this is something you need to memorize. Okay? This is really quick shorthand that will help you, especially in percentage questions. Very helpful in which we'll see percentage questions. We haven't done percentage questions yet, but once they'll arrive, this take us. The reason that I'm spending so much time on day 1 and day 2 is because they lie at the foundation of all the maths. The arithmetic, the basic number theory, they lie in the foundation of all the maths. So if you learn how to do the arithmetics and do it well, maths paper, at least it will be easy to solve the maths paper. Okay, so if you take a pizza and you make 4 slices of it, then of course I convert it. I turned the roller and I converted this pizza into four slices. I cut the pizza into 4 slices. So this slice, the total parts is 4. So this slice is 1/4. Remember the decimal for it. This is what you need to memorize. 1/4 is 0.25. Okay. Just plain remember this. 1/4 plus 1/4, it will be 2/4. I can also write it as 1 divided by 2. If you divide by, you do the cancellation, 2 1s are 2, 2 2s are 4. 1/2 is equal to 0.5. This is the stuff you need to memorize. This is 3 divided by 4. All the denominators are the same, so I could just add the numerators. 3 divided by 4, remember 3.3 divided by 4 is 0.75. Okay, and this is just 1. 1/4, it's just 1. Yeah, so this is something you really need to memorize. Okay, this, that 3 point, I mean, there was a better way to write this, but how about I write it this way? 1/4 is equal to 0.25. 1/2 is equal to 0.5. 3/4 is equal to 0.75. This is just 1. 4/4, any numbers on top and bottom is just 1. But these 3 are really important actually, that you need to memorize. I'm making this workspace look like a maths notebook, but this is important. All of them are important. Okay, so we're done looking at all the 4 cases of how to convert fractions into decimals. Now let's look at some questions and let's convert them into decimals. So 9 divided by, this is pretty simple. 9 divided by 10 would just be, if it's a multiple of 10 at the bottom, so I'll just move it to 1 decimal place to the left. So 0.9 is my answer. 3 over 5, this is not exactly, the denominator is not exactly a multiple of 10, but I could do this to make this a decimal of 10. So it'll be 6 divided by 10, will just be 0.6. I feel like we've done this before. 5 divided by 8, I don't think I can do anything about this. Oh, didn't we just do this? Oh yeah, 5 divided by 8, we just did this. We just did it upstairs. Okay, 2 divided by 3. Again, I'll put a 3 outside, I'll put a 2 inside. So 3, I cannot divide it directly because this is a bigger number. So I'll put 0.36 are 18, 2, 6 are 18, 2, and this is going to be 0.6 repeating. 2 over 3 is equal to 0.6. You can also write it like this, or you can write it like 0.6 with the dot on top. 0.6 with the dot on top. Okay, take a moment and do this. Give yourself a moment and do this. Okay, next, for decimal, how to convert from decimals to fractions. This is the key here. We'll just one topic. Case 2, this is very, very important. This comes in Cambridge, this comes as a separate topic. This comes as a separate topic itself. So this is why I am not doing it here. I'll see, we'll do this on day 3. So terminate how to convert from decimals to fractions. If you're given the decimals and you want to go from decimals to fractions, how would you do that? Well, okay. Well, first of all, you should be able to spot the terminating decimals, right? Terminating decimals, decimals that end cleanly. For example, 0.5, there's nothing after that. 0.75, nothing after that. 0.06, nothing after that. Okay. Count the digits after the decimal. Okay. And well, once you're done counting, make whatever the number you get. Let's say you get 4 digits after the decimal. Then put this number of zeros in the denominator as multiple of 10. What do we even mean by that? Well, how many decimal places is this? 0.5. It's just one decimal place, I'll write 5. One decimal place, I'll write it as 10. Okay. Here's what I mean by that. Okay, I'm trying to be neat here. Okay. So, for example, one decimal place would mean 10. 2 decimal places would mean 100. 3 decimal places would mean 1,000, and so on. Okay, so one decimal place, which means I would put a 10. If you have 2 decimal places, I'll put 75 divided by 100. This is again 2 decimal places, so I'll put 6 divided by 100. Okay, so guys, that is all for today. I will give you the questions in the worksheet. Okay, so make sure to do the worksheet. So that's how you'll get a better hang of it. If you're not doing it by hand, you're not doing it. You're not getting it at all. This is called the illusion of understanding. If you think you're learning by watching, you are not. Okay, so see you on day 3. Take care of yourself, and we'll see you on day 3.